conic sections. So we're going to start our conic sections. We've already kind of covered circles. So we're going to go into an ellipse next. So here's your, read over your definition of an ellipse. There's two types of ellipse we're going to encounter, a horizontal and a vertical. Depending on which axis is longer determines the type of ellipse that we're going to be dealing with. Standard form of an ellipse. Now keep in mind that these standard form equations are when the center is at 0, 0. In just a minute, we'll go over what the standard form of an equation looks like when it is centered somewhere besides 0, 0. Two important points you need to be able to locate is the foci. The foci are the 2 points inside of the ellipse along the major axis. And the formula for calculating your foci is c squared equals a squared minus b squared in this case. All right, example 1. Given 16x squared plus 9y squared equals 144, find the following. So we're going to determine whether the major axis is horizontal or vertical. We're going to sketch a graph, and we're going to locate the foci. So first things first, notice the equation's not in standard form. Standard form should have a 1 on the opposite side of the equal sign. We do not, so we need to get it set up correctly first. So I'm just going to copy my, that's way too zoomed in, 16x squared plus 9y squared equals 144. So to get it into standard form, we're going to divide both sides by 144, which that's crooked. In turn translates to, we're going to divide both terms on the left by 144. All right, so to get our equation into standard form, we just need to get that fraction reduced, the 16 over 144 and the 9 over 144. So 16 over 144 gives us 1/9, so that would be x squared over 9, plus the 9 over 144 gives us 1/16, so y squared over 116, or y squared over 16 equals 1. So looking at this equation, since the denominator of y squared is bigger, I'm going to rewrite it with that in the front because that means it's going to correspond to our major axis. So x squared over 9 equals 1. All right, so because the denominator of y squared is bigger, this tells us that the major axis is going to be vertical. So I'm just going to put since, so that way you've got a reason for it. Since the denominator of y squared is bigger, our major axis is vertical. All right, sketch the graph. So notice I didn't give you a grid. You'll have a grid in the homework. Get my colors all out of whack here. Where's my dark blue? That's not, there it is. So as far as sketching the graph in the notes, we know the center is going to be at 0, 0. So I know my major axis is going to be vertical. So I guess I could make it a little bit smaller, but as long as I get it labeled right, we're good. So to figure out where my minor and major axis are going to be located, I need to find A and I need to find B. So A corresponds with Y because it is the major axis. So if we look at our standard form, we know the denominator of Y is equal to A squared. So we know A squared is 16. So that means our A value is going to be positive or negative 4. So that means we're going to go up 4 units and down 4 units from our center 0, 0. So I am just going to, I don't want to tick mark to death. If you call that 4, I'm good with that. So let's see if I can, I'll try to be consistent and make them equidistant. Copy, paste. All right, get one of them. All right, so there's our 4, and there's our negative 4. So those are going to be the points for our major axis. And then our minor axis is under x squared, so 9. So b squared is 9, so that tells us b is plus or minus 3. So left and right 3 units. So let me get my tick marks done first. Copy, paste. Oops. One direction. So try to make it pretty. So left and right 3, left, right, minor axis points. Let's see how well this thing is going to cooperate with an ellipse. Oh, look at that, beautiful. All right, ellipse sketched. All right, locate our foci. So foci, we know that because, well, c squared equals a squared minus b squared. We've already identified our a squared and our b squared. So c squared equals a squared was 16, b squared was 9, so there's no reason to plug in a and b since we already know the value of them squared. So that means c squared is 16 minus 9 is 7. So c is plus and minus the square root of 7. So as far as locating our foci, make sure you go on the correct axis. Our correct axis is vertical. So we are going to add and subtract the square root of 7 on the y value or the vertical value. So our foci are going to be located at 0 root 7 and 0 negative root 7. Try to get it all up there. Almost. There we go. All right, next one. Find the standard form of the equation of an ellipse with foci at negative 2, 0 and 2, 0 and vertices at negative 3, 0 and positive 3, 0. All right, so first thing we need to do is figure out whether we are dealing with a horizontal ellipse or a vertical ellipse. So I'm going to look at the location of the foci. So we haven't gone over an ellipse that's not centered at 0, 0. So again, this one is going to be centered at 0, 0. So the foci have changed the x value. The vertices are also defined as on that same axis. So because our foci have changed our x value, our major axis is horizontal. So that tells us our equation we're going to be dealing with is x squared over a squared plus y squared over b squared equals 1. All right. So if we look at our vertices are negative 3 and positive 3. So your vertices are equidistant from the center. So since we went 3 units left and right, that tells us that a equals 3. So we know that a is going to be 3 since those two vertices were negative 3, 0 and positive 3, 0. So that means a squared is 9. So I can go ahead and get that plugged in. X squared over 9 plus, I don't know what my b is yet, but I do have my foci and I do have a. That's enough. If you have any 2 of the 3, we can solve for it. So if we just look at the standard form for that equation, c squared equals a squared minus b squared. So if we set this up, our foci were 2 units left and right. So that tells us that c is 2. We already said a squared was 9. So we just do a little algebra manipulation and we're going to get b squared equals 9 minus 4. So b squared is 5. So b is equal to, actually we don't even need to go all the way down to b. We can just stop at b squared since that's what's in our formula. B squared is 5. So then we come back over here to our formula and add y squared over 5 equals 1. All right, moving off of an ellipse centered at 0, 0. So now it's centered at h, k. We've used the notation hk for a vertex before. Now this is just going to represent the center of an ellipse, and it's found in the same way watching this sign in the middle. Minus move left, minus move right, plus move left. And then for your vertical distance as well, it's going to be defined in the same way because they are on the same side of the equal sign. So minus move up plus move down. So that's all your information here. So just transitioning that to the center not being at the origin. All right, so first thing we're going to look at is determining whether the major axis is horizontal or vertical. So that's looking at which one has the bigger denominator. So we're given x plus 1 quantity squared over 9 plus y minus 2 quantity squared over 4 equals 1. So it is in standard form. So if we look at our denominators, the denominator for the x term is larger. Therefore, that tells us that the major axis is going to be horizontal. So major axis is horizontal. All right, sketch the graph. So to sketch the graph, a little more work here. So we need to locate our center first. So our center is going to be, we go left 1 because it uses a plus sign, and then we go up 2. So our center is the point -1, comma 2. All right, sometimes it's easier to go ahead and start your graph. All right, so -1. Whoops, I just erased my axis. I erased both of them. -1, 2. All right, we said our major axis was horizontal, so the next thing I'm going to do is find my points, my new vertices for my horizontal axis. So that's looking at the denominator for x. The denominator for x is a 9, so we know that a squared equals 9. So we'll do this in a different color. Therefore, a is going to be 3. So in the horizontal distance, we are going to add and subtract 3 units. So technically, I guess we could say a is plus or minus 3 because that's what we're going to tack on. We're going to add it and we're going to subtract it to the x value of our vertex. So those points are become -1 minus 3, -4. Do not touch the y value so it stays horizontally aligned. And we do -1 plus 3, which would be 2, comma 2. I'll move my graph more to the right. Scoochy. There we go. All right, for our, I guess we could go ahead and mark those points first. So let's see, we need, what do we need labeled? -4, 2. We'll go this way. I'll call that -4. Going up the same amount, and then we go to, try to make it pretty close. That's close. 2, 2. All right, so for our vertical points, I like to keep all this kind of lined up. All right, so our vertical points, b squared was 4. Therefore, b is plus and minus 2. So this time we're going to add and subtract this value from the y value of the vertex. So this time we leave the x value untouched. So we're not going to mess with the x value for our minor axis. So the x value is going to stay at -1. We're going to take the y value 2 and subtract 2, which gives us 0. Then we don't touch the x value, and then we take the y value 2 and we add 2 and we get 4. All right, so -1, comma 0 and -1, comma 4. So I don't have that one marked, so I need to mark it. So -1, comma 4. I went a little bit high with that 4. There we go. And then we try to bubble it. Let me see if it'll cooperate. Kind of, sort of. It's a little crooked. Try to make it better. So that's what happens when you freehand them. Nice thing with the computer is you won't have to worry about getting it drawn crooked. All right. Locate the foci. So our foci, again, remember, make sure you change the correct one. They are going to be C units left and right, since our major axis was horizontal. So C units left and right from the center. So it's still the same relationship, C squared equals A squared minus B squared. So C squared is our A squared was 9, and our B squared was 4. So 9 minus 4 is 5, so C is going to be plus and minus the square root of 5. So again, from the x value of the vertex. So the x value of the vertex was -1. So our foci are going to be at -1 plus and minus, it's fine to write them as 1, the square root of 5, comma, and then we do not touch the y value of the vertex, which stays at 2. Let me scooch this up just a little bit so it doesn't cut off. All right, example 4. write the equation of the ellipse in standard form. So this time we're given a hodgepodge of x's and y's in here, and we're asked to give the equation of the ellipse in standard form. So this is going to involve completing the square twice, but on the same side of it, of the equal sign. So first thing I want to do is get my terms rearranged. I want the x squared and x beside each other, and the y squared and the y beside each other, because that's how we're going to have to split everything. All right, so I've got my 4 x squared plus 40x, and then my 36 y squared minus 288y, and then the constant's got to go. So we're going to go ahead and move it over, negative 532. All right, remember completing the square, we don't leave a coefficient next to our squared term, so it's got to be factored off just relative to the x's or y's only. So we're going to factor the 4 out of the x terms, which is going to leave us with x squared plus 10x. I'm going to leave some room in there to finish that completing the square. And then I do the same thing with the y terms. I'm separating the 36 from the y squared, which requires us to take the 288 and divide it by 36, which is going to give us 8. Just be careful, it does have a minus sign. And then I'm also going to leave some room in there to finish the completing the square, and then negative 532. All right, so what we're going to do is we're going to add something inside to force that x portion to factor as a binomial squared. But when we add on the left, we also have to add on the right. Just remember, it was also multiplied by 4, so we've got to do both of those things. So I'm going to go ahead and add on the right side as well, but I got to remember to multiply it by 4 because it's sitting inside of parentheses with a 4 in there. Same thing with the y term. We're going to add something in here to force it to factor nicely. But if I add on the left there, I also have to add on the right. I didn't make that box very big. So we're going to be adding on the right. But it has a 36 sitting outside its parentheses. So whatever we get there, we are going to have to multiply it by 36. All right, so formula for filling in those blanks, it's the coefficient of the middle squared divided by 2. So we're going to take 10 divided by 2 squared, and that's what we're going to add for this first blank. So 10 over 2 quantity squared, which is the same thing that gets attached here. 10 over 2 quantity squared. For the y term, negative 8 divided by 2 quantity squared. So same thing here, negative 8 divided by 2 quantity squared. Now we just want to get all that math cleaned up. All right, so for the x term, we've got our 4. I'm going to just go ahead and do the math here. 10 over 2, 5 squared, 25. For the y's, 36 y squared minus 8 y, and then we got negative 8 divided by 2, negative 4, quantity squared, 16. And then on the other side, we want to get our math finished. So we know the 10 over 2 squared is going to be 25 times 4. So we've got, that's 100. And then we've got the negative 8 over 2, 4 squared, 16. So 16 times 36. 576. We're going to go ahead and I'm going to go ahead and do, well, I guess we'll just do the math on the next line. So we've got our negative 532 plus the 100 plus the 576. So then we come back over here, get the x factored into its binomial squared, which is going to be x plus 5 quantity squared. Same thing for the y. 36 y minus 4 quantity squared equals, and then we do the algebra over here. So we've got our negative 532, we're adding 100 to it, and we're adding 576, which gives us 144. And then to get it into standard form, remember it's got to have a 1 on the right side, so whatever that number you get here has got to be divided off from the left and right, so that means both terms on the right on the left get the division by 144. So we've got our 4 over 144. So x plus 5 quantity squared. 4 over 144 is 1 over 36. plus, then we've got our 36 over 144, 1 over 4, so y minus 4, quantity squared over 4 equals 1. And the 36 is the bigger number, so that's the one we want in front. If the y was bigger, we would want to reverse our addition and put the y at the front and the x at the back. So there's our standard form. Right. Example 5. We got to have some word problems in here, just a couple. A semi-elliptical archway over a one-way road has a height of 10 feet and a width of 40 feet. Will a truck that is 12 feet wide and has a height of 9 feet clear the opening in the archway? I gave you a hint. It says put the given information on a coordinate grid and use grid using coordinates where the x-axis is the ground and the origin is the center of the arch. All right, so let's get our picture drawn here. So I really don't need to go below, so we'll just stop it there. All right, so we've got a truck. I'm going to keep it simple. There's my truck. I think I got him pretty centered on there. It says the truck is 12 feet wide, so that means it's going 6 either direction. So point here would be -6. This point here would be +6. And it's 9 feet tall. So I know this point right here is going to be 9. All right, over an elliptical archway that has a height of 10 feet. So a height of 10 feet means it goes up to 10. So here is, let me get some other colors in here. We'll go green. I don't think I've used green. All right, so here's 10. There's the top of my archway. And then it says the archway has a width of 40 feet. So there's going to be 20 feet either direction. So we would come out here, 20. And then we would come over here to the left, 20. Let me see if I can get it drawn nicely where it'll cooperate with me. Look at that. Okay. So that means right here would be -20. So what we're trying to figure out is it going to fit? No, so I know I've drawn it where it's going to fit, but we don't actually know. So we've actually got to calculate some stuff to figure out if this thing's going to fit. All right, so first thing we need to do is figure out the equation of this ellipse. So looking at our axis, we know that the x-axis is longer because those two vertices are 20 from 0, 0. The y-axis, the top of that ellipse, is only 10 feet from 0, 0. So our equation we're looking at is going to be x squared over a squared plus y squared over b squared equals 1. So if I get my a squared is the horizontal distance from the center. The center is at 0, 0, so I go 20 feet from the center. So that means a is going to be 20. If a is 20, a squared is 400. So I guess we'll write a squared equals 400. All right, for b is the vertical distance from the center to the top. We don't need to worry about the bottom because there's only a top. This only the top half of this ellipse. So b is 10. So that means b squared is 100. So y squared over 100 equals 1. So we have our equation. So what we're trying to do, the part in question here is these points on the corner. So like we're trying to figure out if these 2 points are going to clear it. So it doesn't really matter which one we check. If one of them works, the other is going to work too. So I'm going to check the positive. So what I need to know, I can see right here that x is going to be 6. So what I want to know is when x is 6, what is the y going to be? So we're going to plug in 6 for x and we're going to solve for y, and that will give us the y value of that point so we can see if it's going to be above the top of that coordinate or below. So right there. So we know this coordinate. So we know this point right here is going to be 6, 9. So what we're trying to find, I guess I should have put that one a little higher. we're trying to find this one right there. And as long as that Y value is bigger than 9, the truck's going to clear the archway. All right, so at x equals 6. So we're plugging in 6. All right, so we've got 6 squared is 36. I'm going to go ahead and just reduce this fraction rather than clearing my denominator. So we get 36 divided by 400, and that is 9 over 100. We're going to move that to the other side. So we've got our y squared over 100 equals 1 minus that 9 over 100, which is going to give us 91 over 100. Clear my 100 by multiplying both sides by 100. So y squared is going to be 91. We're not concerned with the plus and minus. We're only concerned about the upper half of this ellipse. So when we square root it, we only need the positive. And the square root, let's see, square root of 91 is approximately 9.5-ish. It doesn't say anything about decimals. We're just answering basically yes or no. So what that tells us is that when we plug in the x value 6, the point on the ellipse has a y value of 9.5. So since 9.5 is bigger than 9, the truck is going to clear the archway. So we'll just put a little since 9.5 is greater than 9, the truck will clear the archway, or it will fit, however it is you would like to word that. So it means it's safe to drive under without getting stuck or hitting something. That's the end of your ellipse.